Hello and welcome. It's been a while that I've done a Manfred Mentors, but I have so many things that are exciting to show you all. So I'm going to try to get back into it, a swing of things. And first off, I'm going to start with an open source project that I created recently. So let's dive right in. So as you know, I'm working on a ChainGuard and work on ChainGuard libraries. And one of the things that's been really interesting is rebuilding open source projects from source as they come on Maven Central. I'm a Maven and Java developer myself, so it's been super interesting to work on that. Specifically, if you look at the event log on my website, I presented about is Maven safe for production with Adam Kaplan from Red Hat and myself at the Open Source Summit North America recently. The slide deck is available here on my website, and there's also the video. And for that project, for that presentation, I did a project that's been really fun to play around with and learn more about. And that is my maven-build-requirements open source project. So what triggered that is the interest of understanding what you actually need to build a project with Apache Maven, because typically people are just gonna run and say, oh, well, like I know I run Maven dependency tree, and then I see my dependencies, and that's what I need to build a project. But in fact, when organizations dive into this idea of, well, let's just build everything from source, you'd be surprised how brutally complex that actually is to just build from source. And I'm gonna show you my Maven build requirements project today, because that gives you a bit of an idea what's involved in terms of the sheer amount of dependencies. So if I look at this Maven build requirements project locally here, over here on my editor, you see I have it checked out here locally, and the README has all the information on how to build this project. So I can just go Maven clean install as usual, or Maven package in this case. So if I do that, go to my trusty command line here and go /maven double maven wrapper clean install, it will build the whole project from source, and that's already it. If I go Maven, just a typically analysis dependency tree on this project here, you see this project alone is not that complex, but it already has a lot of dependencies. Now imagine you have to build all those from source. It is more complex because it has a whole bunch of Maven components in it, because it needs to understand Maven projects, but it also has dependencies like package URL, or just plain simple ones like simple logging for Java, like SLF4J and other packages. So this is a simple project. In this project, I also have other example projects, and we'll look at those in a second as well. We built the project. If I look at source IT projects, there's other example projects here. So let's go and look at the quick start example. This is like the simplest and dumbest application you can imagine. It's just using the Maven archetype quick start. And if I go /maven clean install on that, it just builds a super simple application. And then if I go Maven dependency tree, it literally has a very, very small dependency tree, right? So that's just like, you know, basically 2 declared dependencies, and then like 3 transitive ones coming in. And all of them are in fact test dependencies. So they're only needed to actually run the tests in this project, not actually to run the application, whatever that quick start even creates, which isn't much. If you go look at a similar example that's a bit more complicated, so I have another one that's a multi-module example. And if I do the same thing here, build that one, and so you see this is 3 separate modules. If you do the dependency tree on that, you see this is more complicated, but still not crazy. It does it because it's a multi-module module. How the Maven dependency plugin does it, it invokes each dependency tree analysis in that separate module. And you'll see here, there is basically a bunch of dependencies Apache Commons, SLF for J, JUnit, a whole bunch of test ones and some runtime ones compile in this first module. And the second module then has more, again, a bunch of testing and some other like find bugs and like failures and like a simple dependency tree, really. Last one is a bit more complicated again, just to up it one more level. We'll go and look at the Spring Boot example. Again, it's a Spring Framework, Spring Boot example application. And if I run maven clean install on that one, you see I get more dependencies. It runs the application in a test and so on. And then the dependency tree is going to get a bit more involved because, as you see here, it pulls in a whole bunch of Spring Framework things. Like, so it gets pretty heroic. If you wanted to build that from source, truly, it would mean that even in this little application, you would have to build all these dependencies from source. And that's just so you can run the tests, like that's because the test dependencies, and you run the application, so runtime dependencies, and you can compile the application. So on the surface, this looks okay, doable, pretty painful already for a complex application for this, which is just a Spring Boot example, an example application that doesn't really do much. So a real world application would be way, way more. But this is not the complete story. And that's where my where my application comes into play, the maven-build-requirements tool, because it does more than what the dependency tree plugin does. In order to run this, you can build it. And then, as you see in the README, I documented this here in the README, you can run that jar that is created by the build on any Java project. So you can, on any Maven project, so you can copy this jar to wherever you like on your application and then run java -jar in that directory where your project is, and then look at the analysis, and it produces two output files that we will see in a second. And that's what gets really interesting. In order to do this as a simple fashion, hang on, not this. In order to do this in a simple fashion, in the requirements, I have this analyze test projects one as a script that you can just run, and it will analyze those project in source IT projects, right? So let's look at what this does. Or more so, let's look at the output, so to speak. It just flies past here to give you an idea, but we just look at the files because it also writes the same output to files, and that's a bit easier to look at. So where's my editor? Go back here. So we see here in maven-build-requirements directory, source, IT, projects. Let's look at the quick start example first. So the quick start example, as you saw here in the project originally, there's the pom.xml. It only declares these two dependencies, and then the dependency tree was pretty simple. Now, if you look at the results file, the Maven build requirements analysis that my project here makes for you is it detects a bunch of things. So it detects the Maven environment. So in order to build it, you need Maven itself. And if it's well set up, it uses the Maven wrapper. So in this case, it needs Maven 3.9.16, really like pretty new, or if not newest versions. Then it looks at the resolver. It builds the effective module of the overall project. So it needs to look at what dependencies do I get from the super POM. In this case, there isn't any. So it just uses the Maven one itself from Maven 3.9.16. It then looks at all the other things that are loaded. So in this case, you see here, it resolves the dependencies. So that's the 5 dependencies. That's what the dependency tree plugin did. But that's not the complete story, because what you look here next is these are the plugins that are bound in the lifecycle. And the plugins, Maven downloads the plugins from the same Maven repository. So it needs to download all those. Those plugins have parent POMs, which are all those. They need to be downloaded. The plugins have dependencies, which are all those. They need to be downloaded. And you see, even on that very, very simple, plain project, that's a quick start example, which doesn't really do anything, this is the list. So this is like a pretty long list of dependencies you need to build from source if you want to build the whole project from source. Building it, not just like going, oh yeah, I use an existing tool and then I build the components that end up, like actually the whole thing. And the count here is pretty crazy, so we can just keep going down the line. Lots of those will feel familiar, right? Like they're like Maven components, Jetty web server, and other things. Then the Maven distribution itself. So you see in an analysis of result overall, from 5 project dependencies with 0 parent POMs, 13 plugins, 17 plugin POMs, and 399 dependencies and the Maven distribution, you end up with 435 artifacts needed. So 435 artifacts are needed to build this little project from source. So that's a whole nother level of complexity if you wanted to build those from source. Obviously, that doesn't even touch the complexity of being able to build these libraries from source. And the older they were, the worse it gets. Newer libraries are easier to build because the newer versions, they are all already in Git and so on. But like this alone is already pretty shocking. Now let's look at the next one, the multi-module project. Same analysis, right? Oh yeah, and by the way, to also check this out, the other output format that's created is the coordinates.txt. So this is literally a deduplicated, sorted list of all dependencies with the full identifier. So group ID, artifact ID, packaging, and version, and then potentially also any classifiers needed. So that's all. And you see this is like 400 something lines here. So let's look at the multi-module example. Same thing, results. This is a similar result set, obviously. Let's see what's different. Again, multi-module, 3 modules, picks up the same Maven, no super POM, 6 lifecycle plugins, 1 packaging type, so POM and jar, 340 dependencies with 25 plugin parents. Again, the resolved dependencies tree for this example application is a bit bigger. And there's obviously some weird ones like 0, empty to avoid conflict with Guava. Like those are like repackaged weird stuff, right? Like, but those are dependencies you pull in. You never know what's going on until you look at the analysis. You then see the plugins themselves, the parents, POMs from the plugins, the plugin dependencies. So again, this is a long list. Let's go down the list. Obviously, you see lots of Apache Maven and other Apache projects. Again, this project is similarly complex, but has different dependency trees and like different behavior. So it ends up with about 400 artifacts needed. So 1 Maven distro, 19 dependencies on the project itself, 10 plugins, 24 plugin parents, and 340 plugin dependencies, which is also quite a lot, obviously. So that gets truly interesting. Now let's look at the last one, Spring Boot example. You see this one was just a Spring Boot application. The results here again, Maven 3.9.16. Now this one again has super POM from Maven itself, packaging type jar. Then this has 40 dependencies, so this is quite a bit more, right? So you see the Spring framework is a bit more heavy on the dependencies here. And all the different components from the Spring framework, right? Like Spring Boot and all its various dependencies, and then Spring framework itself for running, even though that application doesn't necessarily use all of those, and you could theoretically trim it down, but even if you like to use less runtime dependencies, but to build it, you still need all of it. So you're not going to get around this. So you're going to have to go down through the list, and you see there's a lot. Then there's 2 parent POMs from Spring itself, and then a whole lot more plugins. And then the plugin parent POMs, and then the plugin dependencies. And now we can go swoosh down the list to the result. This project overall, this also is a bit an evolved project. It also has an extension configured, so a Maven extension. It then has parents from the extension. It has dependencies from the extensions. and the Maven distribution. So this one goes crazier. This has 823 artifacts for this very simple Spring application. So you have 100 dependencies on the project alone, 2 parents, 30 plugins, 28 plugin parent pumps, 600 plugin dependencies, over 600, and then also the extensions and the extension parent and the extension dependencies. So this project is also still a simple application with using the Spring framework, but it has 600 dependencies and over 800 artifacts needed overall. That's a pretty big lift. And that's the power of the open source community, right? Like, we all work on this, we pull it all together, and we publish it to Maven Central, and then it's free for you to use. But ultimately, if you wanted to go down your own track, this would be a lot of work, which is why you're probably better off consuming it from Maven Central, or if you want to be even more secure, from the Chainguard repository for Java that I work on, where we take care of this even more. So hopefully that helps you understand that. Please use this project, check it out on your own project. And if you have some crazy cool numbers coming up, let me know. I'd love to see what, like, if there's people that have like larger applications where you'll end up like with multiple thousand artifacts. And don't forget to go back to my website here. I just did another webinar earlier today. So there's my log for writing events and video logs, and also look at all the episodes from Manfred Mentors, and I'll check out some new ones coming up. I have a few ideas of my AI-related workload and work tooling that I've created, and some of this might be useful. So I'll see you in the next episode. Right, that's it. Just gonna switch this off.